Thanks, Adam, for the introduction, the opportunity to speak today. So today I'm going to do a brief introduction to TBS, and then I'm going to run through 4 types of projects that we've worked on over the last 3 years, and just go through some manufacturing challenges in each of those projects, and what we've learned and where we are today. And at the end, I'll wrap up with some of the key challenges in fabrication from our point of view. So TBS was established in 2014, so we've been running for 6 years. We design, engineer, manufacture and install buildings. So it's important to note we're not builders. We are a manufacturing business, and that's what we focus on. Lean manufacturing of buildings. Our wall system's customizable. It's obviously a timber wall system. It's customizable. We build it up to whatever our customers' needs are in terms of internal structure, cladding, and we're capable of up to 7 stories. So we'll talk about the 5-story building we do in New Zealand at the end, but the system is capable up to 7 stories, and we believe we can push it beyond that with some more work. Our production facility in Dandenong here is running 2 linear production lines, very similar to an automotive production line. We're currently just running 1 shift, and we're building about a 2-bedroom apartment each day. We'll talk about integrated supply chain through the presentation. It's very important to manufacturing, and we've come a long way in the last 3 years to integrate our suppliers into a manufacturing business. Manufacturing buildings in Victoria, so all of our buildings are manufactured here, and we're shipping across Australia, mainly into New South Wales, and all of our projects over the last few months have been into New Zealand. So we're exporting. We've been exporting for 12 months now or more. So our philosophy is we're planning to disrupt the construction industry, or working towards it in our small way, based on an automotive approach to manufacturing. So we've adopted engineering, design and manufacturing quality principles from the automotive industry, and we're employing a lot of our staff out of the industry as well. I'll run through the senior team in a minute, but there's over 300 years of manufacturing experience in this business now, both from design manufacture, manufacturing itself, and quality and the quality systems that you need in a manufacturing business. We do turnkey product development and engineering in-house, which is a big part of how we rapidly improve our product to meet our customers' needs. And we embrace a full concept to production automotive approach. So from the design of the product all the way to on-site, using lean principles and processes that most of us in the business have lived through the last 20 odd years of our career, like DFMA, Last Planner, Design for Six Sigma, all those sort of processes that are inbred instilled in an automotive business. We're bringing them into this business. And whilst we don't do each of those processes to the optimal level of detail, we certainly, because we've all lived it, we approach all of the things we do with all of these different processes in mind. We've recently wrapped a integrated management system around the business. It's ISO certified for environmental, ISO 9000 and safety, which sort of wraps in all of the automotive processes into the business systems and how we run TBS. So the TBS leadership team, Darren, our production manager, has 36 years experience at Toyota, so he runs our production facility. He's got a lot of lean manufacturing experience with Toyota, and done various stints in Japan learning lean processes from the Japanese. Ross, our design manager, leads our CAD team. Ross is ex-Holden like I am. He's led a lot of the design of a lot of major projects at Holden, and also done a stint at Hickory, where he's built up his modular experience, and he leads our design team, and he's our main focus on design for manufacturing and assembly. Last year, Fraser joined our team. Fraser is an architect who is doing a PhD in the manufacture of buildings. And he is running all of our projects and our early product development. So we're a really strong team to change the way that we do buildings in this industry. So our system is a fully integrated structural timber wall and floor system. This is the wall build-up. We use a structural timber internal lining. We frame up to whatever the customer's requirements are. Insulation, building wrap, battens and cladding to whatever our customers' needs are. And we have a post-tensioning steel columns throughout the walls as required. So we increase or reduce the number of those columns depending on the style of the building, the overriding loads of the building and what's needed. Exterior cladding, you'll see through the projects, we've used the various numbers of different exterior claddings with different levels of success. But we're happy to give any particular type of cladding a go, except for brickwork, obviously. TBS's approach to quality is aligned with the Toyota Way, which is centered around four key philosophies. Long-term philosophy. So this presentation sort of goes through the various learnings in different projects, and that's aligned with our long-term philosophy of quality. So improving on every project over a long term. The right process will produce the right results. So we're focused on the processes on our production line, the right processes to achieve the quality and the speed that we need to on the production line, because at the end that gives you the right results. We obviously value our people, and we add value by developing the people through the business, and continuously solve root problems drives organisational learning. So we're always looking to solve problems and embed the solutions of those problems back into the business systems. So the first type of building I want to talk about is a building we did at Penrith. This was the first building from our new production line. It's 1,000 square metres. There's a picture of it there. It had timber cladding and 8 metre span. Sorry. And we installed this building in 3 days. You can see here it had a large amount of spotted gum features on the outside that were supported within the walls themselves. And you can see here the waste down the bottom. This was the waste that was left after the construction of the building. All right, so this had floors with a 8 metre span, acoustic floors, and obviously we manufactured this in Melbourne and trucked it up to Sydney on a new transport system we developed. This is the range of some of the panels, over 8 metres long, nearly 4 metres high. So this is a brand new production line. We were stretching the limits of the size of the panels that we could manufacture. So one of the first things we did is when we first started manufacturing these panels is we did a large amount of work on tolerancing of the panels, understanding the variation in the manufacturing processes, our design. So the first 10 buildings, the 10 walls that we manufactured, we 3D scanned those, looked at the variations in particularly the steel columns and the timber work, just to understand, how once that we put it up, how all those walls were going to connect and the variation in the gap between walls, and to make sure that both it was going to firstly go together and.
Yeah, you're back on now. Yep. We're good. That's all good.
One of the benefits of doing a prefab to panelized system is that we can reduce the scaffolding on site or eliminate scaffolding on site. So this particular building, we painted in the factory. We laid out all the panels and painted them. Not very conducive to manufacturing. It took us a couple of days to paint each panel. So for a production line that was running at about a panel per day, we then had to sit panels around and paint them with 3 coats of paint. But we wanted to trial shipping pre-finished panels to New South Wales on the container bases. So this is the first generation one of the container base we did. It's an A-frame that pops up. All the panels are stacked and wrapped on it, and then at site, when the panels are removed, the A-frame drops down. One of the lessons we learned throughout that project is we need to bring structural engineering in-house. We're working with a PhD student at Melbourne Uni, Christopher, I think, is on the webinar, and we brought structural engineering in-house, which has benefited us enormously now with the level of complexity you can see in the photo there of the structural designs in the higher buildings we're doing. We also have access through the broader group to a couple of CPE registered engineers and full-time support for our design staff. So having an engineer in-house means that we have access to him from the staff on the production line, so he's always overseeing the product being manufactured. So our production line is, as I mentioned earlier, 2 linear production lines, a wall panel line down this side here and a flooring line in the middle. It's designed so that as we expand, we can bring material into the center of the line and feed out into 2 lines. So a linear production flow of material, and making sure that we minimize the unnecessary motion of material through the plant. So material coming in will come into the center aisle here and then feed off the lines, add value onto racks, onto trucks and out. So from a lean point of view, we're minimizing that the motion waste of material through the plant. So this plant's developed a lot in the last 3 years from that first building that we're going through now. With the initial building, we only had sort of this part of the line running to build that building. So this is the finished product inside. Big spans, none of these internal walls are structural. All of the structure spans the full 8.8 metres. So then we were looking to move on to another prefabricated building. We were looking for something that was going to be pretty straightforward to manufacture, but this one was far from that. This is a building we did in South Yarra. We added 2 luxury apartments over the top of a shopping arcade. And you can see down here, this is the shopping arcade. We took the roof off, which I'll go through in a sec, and added 2 apartments over the top of it. In this job, we also did planter boxes. The original design had separate concrete planter boxes on the roof of a timber building. So we did some excellent work to integrate these planter boxes into the structure of the building to be able to take the load of the soil and the plants down through the structure of the building. We did the deckings as modules. We did a unique cladding. So this is a anodized black aluminium cladding. We did all of the structural steel in the building. And you can see here all the different panels that we had. So as we went about determining how we were going to install this building, this floor here, the roof was through here. And this was an existing fit out that was removed. And then we 3D scanned the existing roof and then designed a steel structure to hold our building that fitted underneath the existing roof, so that with the roof in place, the support for the building that we're adding could be placed whilst this roof was still on. So then we put all the steel work in, and while we were waiting for the weather to improve, they actually fitted out most of this story of the bottom of the apartments. And there's a video on our website which goes through this build. So then they removed the roof, we removed the roof, and then we dropped on 2 apartments. And you can see here the floor plan of the apartments that we dropped on. So this is the kit of parts, and you can see here there's a large variation in the type and shape of the parts of this building. These are all the floor modules and deck modules, planter boxes. We did roofs that we pre-clad with tin, and all of these risers to take these deck modules on the roof. Separate roof modules. These were wall and floor modules for the stairwell to pop out onto the terrace, and then some really large planter boxes at the top of the building. We had wall modules that had 2 different types of cladding. These walls here on the boundaries, this building could only be prefabbed essentially because you couldn't get to these sides of the building. They didn't have permission to scaffold either side. So these walls had to be placed finished. So all of the flashings and so forth was put on the plant, and as we dropped that wall in, it was already finished. So from a manufacturing point of view, there was no flow, there was no common processes. This was essentially the building was pulled apart, modularized. We built the walls down the production line at a slow rate, and things like the cladding. Whilst we put that on, we designed a special cladding system. We put that on the production line. The walls were then stood up, and we put on these skylights, fire-rated skylights. They were put on in the factory as more like a volumetric type build, and then all of these modules came separately to site. So from manufacturing, it wasn't a very efficient way to manufacture the building. There was no other way of doing this building on site conventionally. So the important thing we learned on this project was around sequencing and installing and what we needed to do up front to ensure that the install went perfectly on site. So we had about 3 days to install this project, and the planning for that started right at the very start. So we broke up the panels, worked out the install rates for each of the panels, and then from that point we started designing the structure around making sure that we could install it in a very short time frame. So this shows the cadence of events through this project. We stripped out the existing interior, installed the structural steel, which I talked about earlier. They framed out the bottom story, and whilst they were doing that, we were manufacturing the building in the plant. So on a Sunday, they removed the roof. We already had the first loaded in the plant, and then come Monday morning, we started installing, and we loaded and installed trucks throughout the 3 days, to a very well-organised time frame. But obviously there was always curveballs that got thrown at us through this install. It was all sort of going to plan through day 5, and then we had a truck coming to our plant at day 6 at 4 o'clock in the morning that had an accident, and we had to reschedule stuff and push stuff out, which was ultimately difficult. One of the important things that we learned was the key to being successful on site is the planning of the loads. We had no laydown area at all, so we couldn't bring trucks in, drop off material and sort them on site and then load them. All of the material had to be loaded in sequence off the truck, so we couldn't have anything out of sequence coming out of the factory. So we did full loading drawings for the whole job. Every component was somewhere on a drawing. You can see here, these are the box gutters, and these are all loaded in the sequence to be delivered on site. And you can see how tight the area was here. So from a planning point of view, it's important to consider a planning system like the Last Planner system, which we did a lot of in automotive. So start with a master plan that overlooks the whole project right at the very start. So major milestones, get everybody who's involved in the install together and understand what each person needs to do over the project to make it successful, and then set up look-ahead plans for each phase of the project to make sure that everything's done at the right time. And then, particularly with this project, as we got closer, we had weekly work plans. Looked at what we needed to do each week. I looked at what had been done, and then you go back and plan the next week's work. So we did that, and we're all ready to go. And then we ended up waiting nearly a month for the weather to clear on this project, because we needed 3 fine days so we didn't flood all the buildings below. So this is an image of finished inside. That's that big wall there. And this is an opening we had, and we put in some windows afterwards. So we finished all of the timber structure in this building off, and then we waterproofed the terrace areas and came back and fitted the planter boxes in the deck a month or so later. So while we were doing that project, we got awarded a couple of jobs into New Zealand. Now these, I'll talk about, these are 3-story walk-up projects, one in Onehunga, New Lynn and Te Rautu. So Onehunga one we've completed, that job's finished. New Lynn just got installed, and this one's Kerbal is just finishing manufacture. So I'll go through each of these 3 projects. So Onehunga, this was a project that was designed. It was not designed as a prefab project. So we got an existing pre-approved, so it had already gone through planning in New Zealand building. So we had to modulise this building without the ability to change a whole lot of the design. And we were quite looking forward to be able to do a large amount of panels that were very similar on our production line and get some throughput. So it's a separate 4 separate buildings, painted cladding that we did locally here. We organised a supply chain where we cut the cladding in our factory to the right shape, went out to an external supplier, it was painted, and it was brought back in at the right time to be fitted to the panel as it went down the production line. We'd also from experience had issues with our external suppliers building our steel columns to the tolerances that we needed. So we fitted out, we brought in-house the manufacturing of steel columns, and we now make them ourselves to the specifications that we need. We did a large amount of structural analysis on the building. You see here a floor module being dropped in, and this is our packaging and how we ship them off to port. So this was the first time we'd shipped a building overseas, and we spent a lot of time with our logistics partners working out exactly how we were going to package panels and floor modules and all the ancillary parts to ensure they got there without issue. So let's get a video of the install. Does that come up, Adam?
Yep. Yeah, coming through well.
So it starts off in our production facility. This is loading onto the trucks. We had a lot of issues with the transport heights of what we're doing. So a lot of what we do is over 5 meters. So we had to bring in a lot of special trailers to drop the load heights down. So this is all the slabs down. All of our panels had already been sitting there. So this is the first building already in place. You can see how tidy the construction site is at that stage. Once the rail was down, this is the guys fitting the rail around the outside of the building. We placed panels. So this was the first time that we had not done the install of the building ourselves. We're selling this building ex-works So it was installed by a New Zealand crew. And there's a few of us over there to train them and overlook the install of this building. But we're still using this same crew now to install the current projects. So floor modules, all of the balustrating and fall protection is fitted on the ground, so that once the floor module is put in place, the floor is intrinsically safe to work from. You can see this guy here is tied on, so he can't go near the live edge. So that balustrading stays on until we drop the next walls down. You see our container bases drop down flat, so we can stack them. We can stack them 7 high and return 1 load. So 7 loads of wall panels go to site, and 1 load of bases comes back. This shot here shows the importance of getting the tolerancing correct. Everything needs to fit together exactly. There's a lot of people here, and this project had a lot of people watching, but essentially we can install a panel with a crane driver, a rigger, and 4 carpenters basically, or 1 carpenter and 3 labourers. So the first building, I think, took them around 3 days to install, a 1 3-story building. By the time they got to the last building, they installed the full 3-story building in a day and a half. So a lot of the things we learnt leading into doing this project is, from a fire point of view, all of our walls had to be 60-minute walls inside and out. So we went through a range of fire testing at Warrington Fire to achieve the 60-60-60 FRL. And we've continued to do that throughout all of the future projects that we've worked on. So now I think we have 4 different cladding types certified, about 3 different wall types. All of the joins between our panels are tested, and that's a joint, the top one on the right, that's a joint test, to ensure that that the system is fully compliant for fire. In fact, the latest wall panel we're doing at the moment has gotten 90 minutes from the outside. Weather tightness is a big thing in New Zealand. Leaky house syndrome and compliance to E2 present a lot of challenges to us on a panelised system. And with some great work done with the Christopher and Melbourne Uni, we verified the seal system that we were using, and we've run full wall and window testing to E2 VM1. And going on from that first project, we've actually built our own water test facility so that we can continue that work as we develop the process. We can see here some modelling we did to verify the gap between panels, and to make sure that within the tolerances that we can manufacture it to, the seal will still work. We've also spent a bit of time modelling some of the building physics and moisture in the walls, and making sure that once installed, the walls are going to dry out and we're not going to end up with mould issues or condensation on the steel columns and so forth. Acoustics, we've done a lot of work on acoustics before entering the New Zealand market, but the test and the way they test in New Zealand is slightly different to Australia. So we set up a new acoustics test example in our factory, and we redid all the acoustic works to make sure that we were compliant with the New Zealand code. And then on this particular first building, we verified the acoustics at every stage of the design to ensure that we were getting the level of soundproofing that we had planned. One of the important learnings out of this is this is talked about a lot. It's talked about a lot in the automotive industry, but it's also talked a lot about in this industry now, is making sure that we make early design decisions. So through all of the engineering development of that building, we were still making a lot of decisions, right up to production, which didn't really give our supply chain enough time to react, and it was a very slow manufacturer. We didn't hit the manufacturing rates that we wanted to hit. We stressed the team out quite a lot heading into the start of this project, trying to get ready to start manufacture. So we've worked pretty hard on our processes now to try to pull all of the coordination of the building early on in the piece, so that it's all done before we enter into our shop drawing process. So we shouldn't really be making any decisions post entering shop drawing. So we have a list of a range of milestones that we run through the project, which is very, very similar to how we've developed cars and progress the design of a car. So the production itself was, as I said, slow. It was we didn't achieve the rates. We had a lot of issues with suppliers meeting their deadlines and understanding the just-in-time nature of what we do. So we had a lumpy supply. We reworked a lot of our lead times to try to bring them earlier. But of course, you try to bring the lead times earlier on the supply of some components means that you need to bring that whole design phase earlier, which doesn't always necessarily work for the design team. So we've been working with some of our key suppliers to get them to deliver parts just in time as required. And on all of our major components now, we have a very good supply chain. Working on some of the ancillary parts still. This is a second project in Auckland. This went up a couple of months ago. It's currently being fitted out. We fixed some issues we had with supply of painted parts. We changed suppliers. We had a supplier was doing batches, which made it very difficult to keep up. We also you can see with all the different shapes of walls, the number of shop drawings for this project was considerably high, and we were challenged with trying to get the shop drawings out in time. So whilst we had fixed our issues with some of the supply around, particularly around paintings, flashings, and some of those unique design parts, getting shop drawings out in time to keep up with manufacturing challenged all the way through this project. We also, the other thing we learned is that we've been chasing buildings that were going to be simple to manufacture and simple to draw, and what we're really doing is mass customization. So if you look at the history of manufacturing, they started off with craftsmen producing parts and into mass production, and then lean production, and then into the 1980s, the sort of turnaround mass customization was developed, I guess. There's not a lot of people doing this, really. There's not a lot of products that you see that are really doing mass customization. But that's exactly what we're doing here. Every single panel that we manufacture is different. So every single panel we manufacture has a different set of shop drawings, and each of our shop drawings are 8 to 9 pages long for each panel. So you can imagine with a project like this one with 102 panels, something like 8 to 15 shop drawings, if you include the columns. You've got a horrendous amount of shop drawings to be drawn, checked, and viewed on the production line. So lumpy production. We were getting there by the end of this project. We had a good rate coming off the end of the production line. We had changed the cladding system. We completely re-engineered this cladding system from the first one to improve the quality, but also improve the manufacturability of the cladding system, removing caulking, adding flashing joints, looking at the tolerance build up in each of the panels and looking at ways of taking up that tolerance to in the flashing joints where we couldn't control it. So a lot of really good manufacturing engineering went into the development of this system. The other curveball that we were thrown through this is COVID. So we couldn't actually go over and be part of this building being put up. So we shipped it off and had to assist the team putting it up remotely. So we had already put in place a quality control system that we barcode all the panels. All the panels have photos taken that are in our database as they're built, which we used for with council and our clients' quality systems. But we had to step this up, and all of the install instructions that needed to install each panel are now linked with a barcode on our system that we built ourselves. And we've also invested in what is close to augmented reality headsets that we are using on site and in the production system, which we've started to use in this project. So anytime they had issues installing a panel or we went to review the quality, we could see live through the headsets what they were doing and assist in any issues or questions they had. So the first run of this has worked pretty well. And now we're fully developing and integrating these two systems so that it's a completely integrated install workflow that we've all developed in-house. So Kerbal Avenue, we're just finishing this project. This is the third 3-story walk-ups we're doing. Complete new cladding system again, no exposed fasteners, new window supplier, new way of doing flashings, a complete remodel of our system. This building was actually designed by our architect on the job intro to be a modular building, and one of the things you can see here is there's a lot of the buildings have got similar shapes, and what this did for us is reduce the amount of time it took us to do shop drawings. So the issues we had on the previous project around doing enough shop drawings to hit the manufacturing speed, we actually got ahead on this project and didn't have any issues with drawings. With the cladding being a colour through from the supplier, we reduced the supply issues. The previous supplier was about a 2-week turnaround on painting the cladding, which meant that we had to pre-cut the cladding and send it out and deliver it to line at exactly the right time with a 2-week lead time, which was immensely difficult. We set up a brand new production line, a separate line for cutting this cladding. So we cut this and we delivered this to the edge of the production line in sequence now, so just in time. So this project, we've got really good flow. This is our buffer zone for the panels at the end of the line, where we can buffer 4 or 5 panels, and we had a very good flow without any wastage of double handling panels all the way through our production line onto the containers ready for shipment. That's one of our loads going out. So all fully wrapped. That's our last load that went out last week. So this complete project of over 150 odd panels is either there or on its way to New Zealand. So we're still working through the whole mass customization piece, and you can see here, this is 4 panels from exactly the same job, and you can see the difference in the size and the content in those panels. So if you think of a linear production line where we're trying to keep a consistent workflow, a consistent speed down the production line, this is very difficult to get a flow out that minimises the amount of downtime on one station. So for instance, this one here is a fairly narrow panel, so it'll run through the framing station fairly quickly, whereas this one here being 9 metres long will go through the framing station twice as long as this one. And then this one here comes off the cladding station, with just a small bit of cladding, within an hour, whereas this one takes hours to clad. So managing that level of complexity in a linear production line is very challenging. And we've got a number of buffering areas and movement of operations throughout the production line to try to minimise that. But we're still trying to solve that fully. So if we look at the cost of prefab, the cost savings on site around safety, reduced time on site, material waste, we save quite a lot in waste in our plant. We actually manage and record our waste live out of our stores now. So we understand exactly where all the waste is in the building. Improved quality, a level of cost assurance. So as soon as we hit shop drawings, we've already often bought most of the components, and we know well in advance what all of those components are going to cost. So there's no surprises on site. It's already pre-done and the cost is already assured much earlier in the program. No need for scaffolding and less lost days on site. So they're all the areas where prefab, and particularly timber prefab, saves you money. But there's obviously some downsides around transport to site. We're lifting and transporting pre-finished panels is quite expensive. So we're always working hard to minimise the cost of that transit. Crane time. So crane time's expensive, and we spend a lot of time early in the design looking at how many lifts, how many rigging changes, how they lift, how they rig it up, how long it takes to land a panel, how quickly you can tie it down and screw it off. And we spend a lot of time in a 4D animation working through that before we even design the first panels, to ensure that we design in at the very front end an efficient install on site. We're careful to watch the additional structure we add into the walls for prefab, for lifting particularly, and the stiffness of the wall through transit, because once the wall's in place, that structure is redundant. So you're adding cost into the structure that is not used again for the life of the building. So we're very conscious to watch how much structure we add in, and we look for creative solutions to achieve the stiffness or the lifting point structure that we need, and not overburden the structure with additional cost. Detailed design, every component is modelled in 3D down to the bolts. We make sure we've got tool access, and that's and it's very expensive. So any of these areas where we can double up on exactly the same panels or very similar panels and reduce the amount of detailed design required, saves quite a bit of money in the project. And factory overheads. Factory overheads pay a large amount of the cost of this style of prefab, and that's why we're so focused on maximising the efficiency through the production facility and minimising the amount of time it takes to put a panel together. And that piece around the mass customisation is important in solving those issues, mass customisation. So this is a finished wall panel for Kerbal. We currently produce one of these about every hour or so, which is the average tack time of our line. Interesting to note, this panel weighs about 1.8 tonne. About 800 kilograms of that is timber, and the equivalent concrete panel would be about 9 tonne. So you can see the level of mass we can reduce out of the building, which results in a reduction in the slab and the footings you need. And obviously, from an environmental point of view, the amount of carbon we're storing to the amount of carbon you're using to generate the concrete building is significant. So We build these panels plus or minus 2 mil at 1 every hour or so. So from a production, from a control of dimensions through the production line, we've learned a lot over the last 3 projects being able to run at a significant pace. All of these individual panels are cut offline. They're delivered to line side to be placed onto this without needing to be adjusted. And we achieve a 10 mil gap at each of these, and then we've got a new system for installing on site, which means that the gap between this panel and the next one, you can't really vary on site. It's very, very difficult to get it wrong. All right, so what's next for us? So this is a 5-story building. We've finished the design of this. We're into shop drawings now. We're about to do line fill. So that means we fill the production line with the first panels, and we pause and we do a quality check and review tolerancing and review our ability to achieve all the dimensions, and get ready to start manufacturing this building. So you can see some of the structure, all of the plumbing and everything's modelled in. We'll pre-cut penetrations where it's all modelled. Pre-do all the connections for the steelwork, external steel, so our bosses coming through our walls to pick up all the external steel and transfer those loads back down through our columns. This is one of the ground floor walls. You can see all the different post-tension columns we've got through here. So this is quite a complicated wall system now, but we have a very good offline process for manufacturing columns and cladding and fire check, good relationship with our window supplier, so they'll be supplied just in time, good consistency in the wall heights, so we plan to manufacture this at a continuous good rate with a high level of efficiency. It is interesting to note, whilst all these panels look the same, they're not all the same. They're about as same as you can make them, but this bottom panel here has a different connection to the slab, which makes this a different set of shop drawings. And then the first floor is a different design due to that connection. You need a floor-to-floor connection. The next one up, we start reducing structure, so it's separate again. We move up another level, reduce more structure, so it's different again. And then as you get up to the top, we have a different detail around the top of it to pick up the roof. So it's very close, but we're still into a large amount of shop drawings. So the way we 3D model this, we've optimized over time to be able to quickly generate shop drawings at a rate that's faster than what we can produce these wall modules. Whilst we're producing at quite a quick rate, I still reckon we've probably got 20 or 30% of optimization to go in what we can do with the staffing levels we've got. We were planning to manufacture this with about 13 staff over 4 months or less, and we'll plan to install this building in 5 weeks with about 6 to 8 staff. So there's a huge amount of efficiency that we're finally seeing in manufacturing buildings at rate on a linear production line. So from a challenges point of view, I've talked a lot about the manufacturing versus mass customization, the difference in panels. At Holden, we manufactured, another car came off the Holden production line about every minute and a half. So you can make a new car, every minute and a half, a new one came off the line. And we had a high level of customization. We did Commodores, Utes, long wheelbase Statesmans, and then we did the short wheelbase 4-cylinder cars. So that was a level of mass customization. but it was a controllable level that they could still get a good line balance and produce a car every minute and a half or so. You know, what we're trying to do here is every single wall module we build is different, and we're trying to develop systems to get a high level of efficiency out of doing that, which we've come a long way in the last 3 years. We've worked with a lot of different building codes. We're now picking the best out of each of those building codes, and all our walls go to the highest level in the aspects of those codes, which we've been challenged through the New Zealand codes for the last 3 years, and what we have now is an excellent wall system that meets those codes. Quality systems very important. We've spent a lot of time on our quality systems, not just for our ISO 9001 certification, but the risk of building products at scale quickly is you start building one wrong, you build a lot wrong really quickly. So we've spent a lot of time on the quality system, not just out in the line, but the quality systems of releasing our drawings and shop drawings, and the quality of the components coming into our plant to ensure that we don't build a lot of stuff wrong really quickly. Late design changes are still an issue, and honestly that's an issue with manufacturing everywhere, but we're spending a lot of effort to work with the teams up front at that very early stages of the planning and reduce those late design changes around good coordination with all the services and making sure that there's no surprises. Transport and logistics. We've transported wall panels and floor panels on trucks and boats all over the place. We've had a lot of challenges around the ports and shipping components, and this is immensely challenging at the moment with the state of the ports between here and New Zealand. But we've come a long way. We have a very good process now for loading frames, getting them signed off and onto boats, and that's all fairly seamless at the moment. We are looking for a project where we can put panels on a train because we've never done that and keen to have a crack at that. Manufacturing business overheads are a constant challenge for any business, any prefab business like ours. We try to reduce the amount of manufacturing time to reduce the amount of overheads we put on any one project, but obviously with reducing the manufacturing time comes you need more throughput, so you need more projects. So we're always chasing the next jobs to make sure that we don't have a period of time where we've got those overheads and no throughput through the plant. Supply chain in the construction industry, some of the suppliers that have only ever supplied to construction sites, get them understand how we need components supplied from a packaging point of view into the plant, from a just-in-time point of view, and so forth. Has been a massive challenge, and we're there on a lot of our components at the moment, and quite a few of the components that we just couldn't get there, we're bringing in the value add in-house and employing staff to do it ourselves, so that we don't stop the line. That was it. Adam.
Thanks, Tim. I'll take the screen back. Yeah, we've got time for a few questions. And there's a comment here from Phil, which I think captures the sentiment in the chat, that there's genuine thought leadership here. The way you have taken the learnings from automotive production and applied them to construction is very compelling. And yeah, totally agree with that. We've got a question from an anonymous attendee, and it popped up in chat as well from Mario. If you're supplying pre-line walls, are you also pre-installing services? If so, how does the relationship with the services trades work from both an installation and certification point of view?
Yeah, sure. So we run conduit in the walls for the cabling, which means that we're fitting the wiring on site conventionally. We spend a lot of time up front in the design to try to run services through parts of the building that we're not manufacturing, which takes that whole thing out of the question. The job we did in South Yarra, we fitted box gutters and roofing on site in the factory, and we got the plumbers that were doing the job on site to come and oversee what my staff were doing on the roof modules. But to be honest, it wasn't efficient and it was costly. So, we're trying to avoid it and design the building so that you don't need to do that. So conduits on site. My module in Adelaide has a good wiring system which doesn't require wiring to the light switches, which, there's things like that coming through that reduce the need for putting services through the walls.
Got a question here from an anonymous attendee. Mass customization has been successful in Japan, not surprisingly considering Toyota's success. Do you think our market is ready for prefab at this scale that Toyota hit it? And I guess you had it when you were at Holden.
Is it ready? No. Does it need it? Yes. The government's just announced 2.2 billion in social housing in the country, and New Zealand's doing a very good job of approaching the way they procure social housing, and they're spending a lot of time on prefab. I think they need it. They're probably not ready. They need to get ready.
Yeah,
because it's what we need to do here.
Alan Oligurk asks, it sounds like a natural variation in project design slows down the production process. Can you have any standard designs to work around this?
So the answer is yes, but we're keen to ensure that our architects can still design a building that looks good. There's no good, I use the analogy here, we don't want to keep building Camrys, which upsets with people from Toyota in the business, but we want to be able to manufacture timber buildings at scale that look great, and we need to allow that mass customization. So what we look at doing is commonising the sub parts of the building that commonising the structure and components that don't change how the building looks, and still allow natural variation in the design.
We've got time for a couple more questions. So another question from Alan. Can you reach the 120, 120, 120 fire rating required for offices? And is that somewhat customizable from a prefabrication point of view to get an increased fire rating if necessary?
Yes. I'll have a crack at 240 if you want me to.
Yeah.
Yeah, no, it's achievable. We've achieved 90 on the wall as it is. We only needed 60. In fact, that
I think I don't know if that was my internet or your internet, Tim, there. But you were saying how fire rating you can quite simply customize it as the project requires.
Yep.
So we might go one final question here from James Harbour. How do you deal with glazing? And it looks like you install it in the factory, but do you work with any particular suppliers?
We install glazing in the factory. We have some of the larger panels. Our supplier supplies the frame to the factory and glazes the frame, but we'd like to avoid that. We find ways of bringing in the windows pre-glazed, and we work with Rylock at the moment. We're a very good supplier.
Yeah. Thanks so much for coming on the webinar today, Tim. Anyone watching today, there's a fair bit going on in the chat, but feel free to share your appreciation in chat, and I'll share it with Tim as well. So thank you so much.
All right, thank you.
And everyone else, just before you go, just a reminder, Wood Solutions in Focus, you can look how different products are made behind the scenes, and this can be found on YouTube, which I highly recommend you go to. And so today is the last of our Thursday series webinars, but we've got one on Tuesday, which is timber construction for social housing providers. As Tim said, I think it was about $2.2 billion. Either way, it's a lot of money going toward it. So we're going to be focusing on what the mid-rise timber solution looks like for social housing, assuming the cost and also carbon savings are part of the goals there. So thank you everyone for joining us today. Please sign up for Tuesday. And other than that, enjoy the rest of your day.